take a bucket of ice and measure the temperature using thermometer, and you start heating. No matter how much heat you provide, the thermometer will always show the temperature as 0 degrees Celsius. As long as there is some ice remaining in the bucket, the temperature always remains 0 degrees Celsius, no matter how much heat you provide. So what is happening to all this heat if the temperature is not increasing? Where is all this heat hiding? To understand, let's take a closer look. Molecules in solid possess kinetic energy, and hence they are in state of constant motion. There are also forces of attraction between them, which keeps them bonded. What would happen if you provide heat energy? The kinetic energy of the molecules will increase and they vibrate vigorously. More the heat you provide, higher the kinetic energy will go. But there is a limit to which you can increase the kinetic energy. Providing heat energy above that would not serve to increase the kinetic energy, but instead break the bonds of attraction, causing a change in state of the material. The temperature of the material stays the same, as the kinetic energy is not changing, but the internal energy of the material changes as the work is done to overcome the intermolecular forces of attraction. The amount of energy required to change the state of 1 kg of an object is known as latent heat. Latent means hidden. As we have seen, it appears that the heat is hiding somewhere as it is not increasing the temperature. But instead, the heat is used up to overcome the forces of attraction between the molecules. Latent heat can be found out using the formula Q equals to ml, where Q is the amount of energy required, m is the mass of the object, and L is the latent heat of the material. Latent heat are of two kinds. When a solid turns to liquid, it is known as latent heat of fusion. When a liquid turns to gases, it is known as latent heat of vaporization. Let us look at how do you set up an experiment. First and foremost, look at the formula which you will use to find the required quantity. In this case, we want to find the latent heat. Rearrange the formula with latent heat as the subject. Now you have L equals to Q by M, where L is the latent heat, Q is the heat supplied, and M is the mass of the object. In order to find L, you need to measure Q and M. Mass could be measured easily using a weighing scale, but what about the amount of energy supplied? For that, you use electrical heater which has the power rating given. Then you can use the formula power equals to energy over time. Hence, energy will be equal to power into time. As the electrical heater will have the power mentioned, all you need to do is measure the time you use it to heat the material. Now let us set up the experiment. You will need a funnel filled with crushed ice. Immerse an electrical heater completely into the ice. Wait for some time until the funnel, the electrical heater are both at the same temperature as ice. Start the heater and wait for a steady stream of water to flow through the funnel. Start collecting the water and start a timer. After the elapsed period has passed, stop heating and measure the mass of water collected in the beaker. Then you can use a formula L equals to Q by M, where mass of the water has been measured, and using the time and the power rating of the electrical heater, you can find the energy. In order to find latent heat of vaporization, take some water in a beaker and measure its mass. Now immerse an electrical heater completely into the water inside the beaker. Wait for some time until the water, the beaker and the electrical heater are at the same temperature. Start heating and start a timer. After the required amount of time has elapsed, stop heating and measure the mass of the beaker in water again. The initial mass minus the final mass will give you the amount of water evaporated. Multiplying the time taken for heating, the power rating of the electrical heater will give you the amount of energy required. Use the formula Q equals to ml to find the latent heat of vaporization.